1 in omega naught t. So this is basically your Fourier series expansion of the square wave that we saw above. Okay, I hope this was clear. From this, we will move on to the second question for today. Question 2. It's basically similar to the previous question, but there is a small difference in the waveform. Consider the periodic square wave x of t shown below. Okay, something like this. Okay, basically this is t naught by 4 minus t naught by 4 here, and this is again t naught and 2t naught and so on. The amplitude is equal to a x of t. Okay, so what is the difference between this question and the previous question? In the previous question, you see the waveform. It was something like this. From 0 to t naught, I had a and then 0. Okay, so your this was something like this. But in this question, it is not from 0 to t naught I have. It is not like that. It is from it is already containing a plus a from minus t naught by 4 to plus t naught by 4. You understand? Your earlier case was something like this, but now it is something like this. It's basically a shifted version of your previous signal in time domain. Okay, shifted version in time domain. Basically, you need to solve for this. Okay, basically the question is find the complex and trigonometric Fourier series of x of t. Okay, let's just up to the definition. Solution. So what does it want? You want to be for complex exponential. You want to be able to represent x of t as summation k equal to minus infinity to plus infinity ck e raised to jk omega naught t, where omega naught is nothing but 2 pi by t naught. See, what is a fundamental period is t naught again. See, this is basically a fundamental period. Oops. Let me draw the fundamental period. This is your fundamental period, and this is precisely equal to t naught. Okay, basically this width is same as this width. That's why I shifted by left amount. So this is basically a fundamental period. And after every t naught, the signal repeats. So then what you have is omega naught equal to 2 pi by t naught. Okay. Then what remains is to find ck. What is ck now? Ck equal to 1 by t naught minus t naught by 2 to plus t naught by 2 x of t into e raised to minus jk omega naught t. That is over one integral, one period I need to integrate. I am taking the period as minus t naught by 2 to plus t naught by 2. I mean the interval of period integration. Okay. Where will minus t naught by 2 to plus t naught by 2 located? This is minus t naught by 2. And somewhere here is your t naught by 2. Okay. This is basically expression for ck. Now but you see, from t0 by 2 to minus t0 by 2 to minus t0 by 4, the integral is 0. I mean, the signal is 0. Similarly, t0 by 4 to t0 by 2 is also the signal is 0. Only between minus t0 by 4 to plus t0 by 4, the signal has a non-zero value equal to a. Therefore, this is same as 1 by t0. I'm just writing this down. 0. X of t, that is a, plus 0. Okay. That means this will go to 0. This will go to 0. So what remains is just the middle term, and this is nothing but a by t0 minus t0 by 4 to plus t0 by 4 power minus jk omega naught t, which is same as, now just integrate it. A by t0 into e raised to minus jk omega naught t by, sorry, dt, right? dt by minus jk omega naught from minus t0 by 4 to plus t0 by 4. Same as a by t0 minus j k omega naught into t0 by 4 minus j times k omega naught t0 by 4 by minus jk omega naught. This is same as a by jk omega naught t naught. So there is a negative here. So I will then make negation of this. Okay. So negative in the minus sign in numerator denominator should get cancelled. So writing this as into e raised to jk omega naught t naught by 4 minus jk omega naught t naught by 4. But what do I know? I know that omega naught equal to 2 pi by t naught. It implies that omega naught t naught equal to 2 pi. So call the above equation as 1 and this is equation 2. Put 2 in 1. What do I get? I get a by jk 2 pi into e raised to jk pi by 2 minus e raised to minus jk pi by 2 by, yeah, that's all. Okay, but this is nothing but, you see, this is, I'm going to rewrite this as a by k pi into e raised to jk pi by 2 minus e raised to minus jk pi by 2 by 2j. Now, can anyone tell me what is this quantity?
Sine pi by 2.
Correct. Sine k pi by 2. Okay. Sine k pi by 2. So that means your ck is equal to your ck. Whereas this is what we started with. Your ck is equal to a by k pi times sine k pi by 2. But now what is sine k pi by 2? Let's analyze. Again, let me take the case k not equal to 0. If k is even, okay, then basically you can write k equal to 2m. For some number m, some integer m. So ck equal to c2m equal to a by 2m pi into sine of 2m pi by 2. 2 to get cancelled. What is this? Is always equal to 0 because sine m pi for any integer m is always 0. But if k is odd, then you can write your ck, that is, you can write k equal to some 2m plus 1 for some m. Then ck is equal to c2m plus 1 equal to a by 2 2m plus 1 times pi into sine of 2m plus 1 times pi by 2. Now this is same as a by 2m plus 1 into pi by 2 into sine of 2m pi by 2 plus pi by 2. Now what is sine pi by 2 plus theta? Yes.
One.
It is cos, right? Cos 2m pi. Cos theta, right?
Yeah.
Right?
Yes.
So then 2 get cancelled. This cos m pi. A by 2m plus 1 into pi into cos m pi. Now what is cos m pi? It will alternate between 1 and minus 1. Right? Cos, for example, cos pi is equal to minus 1. Cos 2 pi is equal to 1. Cos 3 pi is minus 1. It keeps on alternating. Okay. And in general, for any odd value of m, for example, m equal to 1, cos pi is minus 1. That is, for every odd value of m, it is equal to minus 1. For every even value of m, cos m pi is equal to plus 1. So this I can write this as a by 2m plus 1 into pi into minus 1 power m. Is it okay? I hope it's okay. Fine. So now I found out the values of ck for both even and odd. Now let's say k equal to 0. That means just go back to the definition of C naught in our formula. C naught was nothing but 1 by T naught from 0 to T naught x of t dt. Okay, this you can again show that it comes out to be A by 2. Just the average DC component. Okay, so now you have all the values of C naught, C odd, and C even. Just substitute for all these values. Okay, then you can show that your Fourier series x of t equal to A by 2, that is C naught, plus A by pi summation m equal to minus infinity to plus infinity minus 1 power m by 2m plus 1 into e raised to j k omega naught t, right? But k is equal to 2m plus 1 into omega naught t, where omega naught equal to 2 pi by t naught. Okay, this is basically your complex exponential Fourier series. Okay. Now for trigonometric exponential Fourier series, what do we do? Simple. Now I know all the values of CKs. I know there is a one-to-one relation between your AK, BK in trigonometric series with the CKs of complex exponential series. You remember the formula from previous class. Then let's do that. Okay. For trigonometric, we know that your A naught by 2 equal to C naught equal to A by 2, which means your A naught is equal to A. Then your A2m, that is the even values of A, is nothing but 2 times real part of C2m. Why? How? Because your x of t is real. You see, it's just two values. It either takes a value A or it takes a value 0. That means both are real numbers. Therefore, your x of t is real number, real signal. For real signal, you recall that your relation between A and C is given by this number, this equation. But for whenever your k, that is k is equal to 2m, that is whenever it is an even number, so A2m is which is equal to 2 times real part of C2m, but C2m is itself is 0. Therefore, this becomes A2m will also become 0. Of course, m is not equal to 0 because for m equal to 0, I have a not equal to a. Now, similarly, your A 2m plus 1. A 2m plus 1 is what? 2 times real part of C 2m plus 1. It is nothing but what is C 2m plus 1? You go back here. C2m plus 1 is nothing but a by m 2m plus 1 pi times minus 1 power m. And real part of this is really completely a real number, right? There is nothing complex about it. So real part of this is same as this number itself, right? So you just get as minus 1 power m into 2a by 2m plus 1 into pi. Okay, that is for A. For B, similarly, B2m equal to 2 times real part of, equal to minus 2 times imaginary part of C2m. But anyway, C2m is 0, so this is also equal to 0. Similarly, your B2m plus 1 equal to minus 2 times imaginary part of C2m plus 1. What is the value of this? See, what is C2m plus 1? This guy. This is basically your C2m plus 1 is equal to this number. What is the imaginary part of this number? Yes, can anyone tell me? See, is there any j term here? A is a real number, m is a real number, pi is a real number, minus 1 is a real number. Where is the j term here? There is really no complex, right? Where there is no j term. So what is the imaginary part of this number?
C.
Correct. It is 0. Therefore, this is also equal to 0. That means your B odd and B even both are 0, which means for Bk is equal to 0 for all k. Okay, which means your Bk is equal to 0 for all k. So now recall what was your trigonometric Fourier series definition? Your x of t should be of the form a naught by 2 plus summation k equal to 1 to infinity ak cos k omega naught t plus bk summation sin omega naught t. Is it correct? Okay. But now what I'm saying is for every k, this guy is equal to 0. As bk is equal to 0 for all k. Therefore, second term is completely vanished. Now, the first term a naught by 2 is what? I know that a naught by 2 is equal to c naught equal to a by 2 itself. Therefore, this number will be nothing but a by 2. And then what happens is only the middle term. And even for a case, only the odd a case will have some non-zero value. Even a case are equal to 0. Okay. Then I'm going to take only those odd summations so that I can write it as summation m equal to 1 to infinity a 2m plus 1 into cos 2m plus 1 into omega naught t. And this is really a by 2. A 2m plus 1, I got the expression here, minus 1 power m 2a by 2m plus 1 into pi. You can write this as 2a by pi summation. Okay, it's actually 0, not just this is equal to 1, but when it is m, if you write 2m plus 1, I should start from 0. Only then 2 times 0 plus 1 will be equal to a1. You're starting from a1. So m equal to 0 to infinity. M equal to 0 to infinity. Minus 1 power m, which is basically this number. See here, there's a minus 1 power m and there's a 2m plus 1 in denominator. The 2a by pi I've taken outside. Then you have minus 1 power m by 2m plus 1. Okay, into cos 2m plus 1 into omega naught t. For example, this is nothing but a by 2 plus 2a by pi into cos omega naught t minus 1 by 3 cos 3 omega naught t plus 1 by 5 cos omega naught t, and it keeps on going infinitely. So what do you observe? You observe a DC term, that's a constant term, plus multiple odd harmonic. You have omega naught, 3 omega naught, this will be 5 omega naught, right? This is 5 omega naught, and 7 omega naught, 8 or 9 omega naught, and so on. Okay. Therefore, x of t contains odd harmonics. Okay. So the basically the difference between this question and the previous question. See, what is the Fourier? Look at the Fourier series of previous question. Okay, I did not copy, but if you look at this expression, if you go back to your previous notes, what you observed was this will have a trigonometric Fourier series expansion in terms of sine omega naught t. Okay, this, if you recall the last class, this also had sine omega naught t, sine 3 omega naught t, sine 5 omega naught t, 7 omega naught t, and so on. But that was for this signal. Okay, previous signal. But now if you time shift it and make it as a even signal, then what you have is the same kind of a trigonometric expansion, but in terms of cos, not in terms of sine. But the same odd harmonics will still remain. The gist is that any square waveform taking values between 0 and a will always contain odd harmonics, not even odd. No even harmonics will be present. Okay. Now, why does this contain cos? And why does that contain even sine? The previous question contains sine terms. Can anyone try to guess? The hint is this particular picture. Why should this contain cos terms and not sine terms? Why should the other contain only sine terms and not cos terms?
So due to the periods,
Sorry, due to what? I didn't hear you properly.
due to the periods, yeah, in the first question it was start from 0 to directly t naught we were having, and here we are having minus t naught to t naught divided by 4 to t
Ah,
naught divided by plus t naught divided by 4.
correct. So what's happening is that by shifting the previous signal to left by minus t naught by 4 amount, this signal, you see, it's the even signal. See, it is symmetric about your y-axis. This is an even signal. And for recall your trigonometric Fourier series property. For even signal, all your bk should be equal to 0. Okay, which is exact. Oops, sorry. For your even signal, all your bk should be equal to 0, which is exactly what we have also found here. You see, bk's are all 0. That is the reason why it should not have sine. If sine were there, you cannot preserve the even property of your signal, because sine t is not an even signal, it's an odd signal. Okay, but whereas your cos terms, your cos signals are always even signal. Cos omega naught t, cos 3 omega naught t, cos 5 omega naught t, whatever cos 2m plus 1 omega naught t it's an even signal. But your sine terms are not even signal. That's the reason, it's since your original signal is even signal, maybe you should emphasize that. Okay, this is an even signal. You don't have sine terms. You should not have sine terms. Otherwise, the even nature of the signal cannot be obtained. On the same note, you now go back to the previous question. See, this is precisely an odd signal, because if I take x of minus t, this will become exactly the something reverse. You will get something like this. Okay, the complement of this signal will be equal to x of minus t. This is an odd signal. Okay, for odd signal, recall your property that your A case must be 0 and B case should be non-zero. Why? Because only if A case are 0, the cost terms should not be there. If cost terms are there, it will not let your signal to be odd. Only sine terms can make your signal to be odd. Okay, so that is this observation. It's basically all these facts. If you analyze in detail, you will reconcile, and it's basically a nice way to do checking. It's basically a way to verify whether whatever answer you're obtaining, it is correct or not. Okay, that is one trick. Okay, now let's solve another question. This is question number 3. Now I'm going to give a different square wave. Okay. Consider the periodic square wave shown below. What is the signal? X of t. Okay, let me draw it properly. This is the square wave. Okay, it oscillates between two values, a and minus a. And again, t naught by 2, t naught, 3 t naught by 2, and so on. Minus 2. So the question is, find the complex and complex exponential and trigonometric Fourier series expansion of x of t. So what is the main difference? The main difference between the previous two questions from this question is that there you had only between a and 0. But now the 0 is now pulled to minus a. So in fact, this is same as your first question, not the second question. It is, see, let's go back to that figure. It is same as this, except that wherever you had 0, these things are now pulled down to minus a. But this are pulled to minus a. Okay, that is the main difference between the current question and this question. So now what I'm going to show you is the answer to this question. Yeah, you can always do this kind of a method, like find your CK using this integration method, and then find for different k even, k odd, and then find for k equal to 0, and then substitute it, and then you can find the Fourier series. Then you can similarly use the corresponding equivalence between CKs and AK, BK, and then find all AK, BK, and again find the trigonometric exponentials. You can all do that, no problem. But
Sir,
now I'm
small
going
doubt,
to,
sir.
yes.
Sir, excuse me, sir. Sir,
Yeah, yeah.
in this case, sir, in this case, we can say whether it is odd or even, because in one cycle A goes to positive and in another cycle goes to negative. But in the previous case, A is always positive, na, sir. Then how would you decide whether it is odd or even, sir?
No, there it will become A and 0 will become, where this question.
In this question, sir, A is always A is always positive, sir. Then how would you
Correct.
decide it is even?
No. So whether or not something is even, what does it mean? It should be symmetrical about your y-axis, right? That is the meaning of
Okay, sir, okay.
even. It is symmetrical,
Okay,
right?
sir,
This is
okay.
symmetrical about
Okay, sir.
y-axis. That's why it's even. But there
Okay,
it's
sir, okay,
exactly
okay.
the reverse, anti-symmetrical in the first question. That's why it was odd signal.
Okay, sir, okay, right, sir. Thank you.
Yes. So most of at least in signal systems, wherever possible, try to first draw the diagram of the signal. Of course, not every signal you can accurately draw the diagram. You can plot it using rough hands, but wherever possible, plot it using rough hands, and then try to analyze some properties of the signal. The reason being that when you do mathematically and then find the final answer, you can then verify whether the final answer is satisfying the properties that you know. For example, we know even signal must satisfy some properties, and check whether the answer that you get are satisfying these properties or not. If they're not satisfying, that means there is some mistake that you have done in your mathematics. It's just a way to verify. Okay, so now what I'm going to do is this particular problem, I'm going to solve it, but in a different way, only to show you that you can use multiple methods to solve the problem. I'm not going to go by this conventional method of finding CK and then plugging it into the expression. I'm going to relate this signal to the first signal. Okay, let me show you what I'm doing. Recall if x1 of recall, okay, consider the signal. Consider the signal x1 of t as, you have x1 of t. Okay, maybe I'll draw it properly. This is x1 of t, some other color maybe. Okay, and the amplitude of the signal is 2a and 0. And it's between t naught by 2 to t naught by 2, t naught, 3 t naught by 2, and so on. It is minus t naught by 2 and so on. Okay. Now, basically, what I'm going to ask you is, can you relate? I'm zooming up, zooming out a bit. Can you relate x1 of t and x of t? How are x1 of t and x of t related? Yes.
X of t is symmetrical to x-axis, whereas x1 of t is not symmetrical to x-axis, as per me.
Yeah, that is correct. But what I'm asking is, can you get, so let's say I have x1 of t. Can you do some operation on x1 of t and get x of t? Some mathematical operation do on x1 of t and get x of t.
Yes, in x1 of t you have mentioned 2a, whereas in x of t you have mentioned just a, and at the negative section minus a.
So now, okay, what I'm going to ask is, can you construct, let y of t be equal to x1 of t minus a. Now tell me, how does y of t and x of t compare? What is the relation between x of t and y of t?
Both are odd signals.
No. What I'm asking is, I mean, our x1, x of, so if I do, what is y of t? Okay, let's do this y of t. So basically, x1 of t minus a. So basically, if I construct y of t, how will it look like? It will look like something like this. Okay, so whenever it is from 0 to t by t naught by 2, 2a minus a is what?
A.
Is a, correct.
Yes, sir.
Now from t naught by 2 to t naught, 0 minus a is minus a.
Minus a. Yeah.
Similarly, a here, minus a here. Okay, and it goes on. Now tell me, how is y of t compared to x of t? This is x of t, this is your y of t. What is the relation between them?
Y of t is equal to x of t minus a.
Y of t equal to, sorry, this is y of t. Let me maybe zoom out a bit. Okay, I'm showing all the three pictures here. X of t, x1 of t, y of t. I'm asking you the question, how is y of t and x of t related?
Both are same.
Exactly, both are same. We observe y of t equal to x of t. Therefore, what does it mean? It means that your x of t can be obtained as x1 of t minus a. Right? x1 of t minus a. What does it mean? Why did I go by this approach? The reason is, you see, x1 of t, what is x1 of t? It is really the signal, the first question signal. You see, go back to this question. It is exactly this signal, except that a is equal to 2a. Correct? Except that a equal to a, this is exactly your x1 of t. So now the thing is, and I know the Fourier series expansion of x1 of t. Correct? I know what x1 of t is. Fourier series, I know the Fourier series of x1 of t. So, and then just subtract a. So basically the Fourier series expansion of x of t will be the Fourier series expansion of x1 of t minus a. That's all. So basically what I'm trying to show is, if I know the Fourier series of some other signal already, and if I can establish the relation between the asked signal and the known signal, then Fourier series will also be direct. You need not go through the computation of CK, AK using the integration techniques and all those things. Okay, so let me now basically write it down. Okay, therefore, from first question, x for x1 of t, it is how is x1 of t? Your a is replaced by 2a. Okay, your a is replaced by 2a. From first question, replace a by 2a. Therefore, the Fourier series expansion of x1 of t is what? Let's go back to the expression. This one, this expression. This was the expression. Oops. Okay. The Fourier series expansion of x1 of t is this expansion, except that now a should be equal to 2a. This a should become 2a, and this a should become 2a. Otherwise, the Fourier series is exactly this. Okay. And I'm going to write down the answer here. Okay. It is equal to a plus, I remember I had a by 2. So if you do a as 2a, it's 2a by 2, which is equal to a. That's it. A plus 2a by j pi summation m equal to minus infinity to plus infinity 1 by 2m plus 1 into e raised to j 2m plus 1 into omega naught t, where omega naught equal to 2 pi by t naught. Is this clear? This is basically my x1 of t. Now call this as 1, call this as 2. Therefore, put 2 in 1. What do I get? X of t equal to this a and minus a will get cancelled. And so what you will be left out is just 2a by j pi summation m equal to minus infinity to plus infinity 1 by 2m plus 1 to e raised to j 2m plus 1 into omega naught t, where omega naught equal to 2 pi by t naught. Now, what is this x of t? It is I have expressed x of t as a summation of complex exponential with appropriate coefficients 2a by j pi into 1 by 2m plus 1. That means this is a Fourier series expansion of x of t. Is this clear? I mean, did you understand the way I solved this problem? Can anyone confirm? Yeah.
Yes.
So basically, I'm just showing another way to solve a problem by using the result from some other problem. That's all. Okay. But now the next question is, what is a trigonometric Fourier series? Again, what you need to do, you need to go back to the trigonometric Fourier series of your first problem, replace a by 2a, and then subtract a to it. That will become the trigonometric Fourier series expansion of the current problem x of t. Let's just, maybe I'll just give the final expression. You can check it up. Okay, fine. Again, you see you only have sine terms. That's because this is an odd signal. You see, it is not symmetrical about your y axis. It's exactly anti-symmetrical. Okay, it's exactly anti-symmetrical about your y axis. It's an odd signal. That's why it contains only sine terms in the trigonometric expansion. So this is about the third question. The fourth question is as follows. Okay. Consider maybe let me solve this question. Okay. Consider the triangular wave x of t as shown below. Okay. How is the triangular wave defined? It's something like this. T x of t and goes on. Similarly, you have, and this also goes on. The amplitude is equal to a, and this is basically t naught by 2, t naught, 3 t naught by 2, and so on. Similarly, here this is minus t naught by 2, and so on. Okay, this is 0, of course. The question is, yeah, find complex exponential, maybe it's okay. Fourier series, and B, find trigonometrical Fourier series of x of t. Okay, so basically, again, this is a periodic signal. Okay, and I want you to find the Fourier series expansion. Again, yes, for one direct way, a naive way to do this is go back to the expression for ck, compute the integral under this curve. First of all, for that, what you need to do is you need to find the expression for this line. I know, okay, this is nothing but 0, 0. This is nothing but t naught by 2, a. Find the equation of this line. Similarly, find the equation of this line. Write x of t in terms of the split function, and then use this in the integration, ck integration expression. And then you keep on proceeding, and then that's a mathematically laborious way to do. That is one way to solve the problem. Now I'm going to introduce another way to solve the same problem. Okay. What I'm going to do is, okay, I will now ask this question. Okay, so let's first do. Consider another signal x dash of t to be equal to d by dt of x of t. Okay, I want to differentiate the above signal with respect to time. How will the signal be? Okay, but this what I'm asking is, what is the slope of the signal at every time instant? For example, if you see this is a straight line, which means the slope is constant in all this region. What is the slope? I need to find the slope. Correct? So basically what I will do is first I will write down the expression for x of t. So basically x of t is nothing but so this is nothing but t naught by 2 comma a. Fine. So x of t is nothing but 2 by t naught a times t from t between 0 to t naught by 2. Is this clear? For example, if I substitute small t equal to t naught by 2, what do I get? I get equal to a. So this line equation is this one. 2 by T naught into A by T. Correct or not? Now, similarly, what is this? So this now what I will do is I will compute the equation of this line. So basically, this is nothing but T naught comma 0. It's a coordinate T naught comma 0. So what is the equation of this line? Let's do it properly. I mean, let's do this. Okay, we all know coordinate geometry. So this is nothing but y minus y1, that is equal to 0, equal to y2 minus y1. Let's say a minus 0 by x2 minus x1. T naught by 2 minus T naught into x minus x1. X minus T naught. Correct? That means your y equal to 2a by T naught into T naught minus, sorry, this is not x, this is T naught minus T. Okay, that is basically y is nothing but x of t here. Okay? Y is nothing but x of t. I just computed the equation of this line. Which line? This line. Then it's 2a by T naught into T naught minus T. 2a by T naught into T naught minus T. From whenever T is between T naught by 2 to T naught. Okay. Now tell me what is d by dx x dash, that is basically your x prime of t, x dash of t equal to d by dt of x of t. What is this? Tell me. Yes. Yes. Can you tell what is d by dt of x of t?
Sir, a t square by t0, sir. Oh,
A
two,
t
4 a t square by t0.
4a t square by. Are you doing integration?
Okay, sorry, sir. 2a by t0, sir. Sorry.
Yeah. 2a by t0. That's correct. From 0 t naught by 2. Similarly, what about this second one? Sorry, can you repeat again? I was not able to hear you.
Minus 2a by t0, sir.
Correct. Minus 2a by t naught. From. So how does it look like? See, t0 is all constant. T0 is a constant. Okay, remember that. So if I plot the diagram of x dash of t, how does it look like? From 2a by t naught, the amplitude is 2a by t naught. And then minus 2a by t naught. Again go up, 2a by t naught. Again go down, go up, go down, go up, go down, go up. So is it okay? This is basically your x dash of t as a function of t. Okay. Now, precisely, we already know the Fourier series of this question. You see, our previous question was exactly this. This was our previous question, except that now a is replaced by 2a by t naught. Okay, except that a is replaced by 2a by t naught. Then basically what it tells is you compute, we know the Fourier series of the differential version of the actual signal. From that, try to get the Fourier series coefficient of the actual signal x of t. Okay, that is the idea. Let me now write down let's write down the Fourier series of x dash of t. Fourier series of x dash of t from, okay, maybe let me use a different color. Fourier series of x dash of t from question, what was the question number? This is question 4, question 3. Yeah, from question 3, when a is replaced by 2a by t naught is what? Just go back. What is this Fourier series? That's this, right? This is basically my. Let's first do complex exponential. Same in the same way, you will also do your trigonometric Fourier series. Okay, so basically you replace these guys a by 2a by t naught. That means your 2a will become 4a, and you'll have an additional t naught here. So means 4a by j pi t naught times this entire thing will remain same. Okay, what do you get? You get equal to, that is x dash of t equal to 4a by j pi t naught. The summation same. M equals minus infinity to plus infinity 1 by 2m plus 1 into e power j 2m plus 1 omega naught t. Okay. Again, note down this t naught you should carefully take on. This t naught by 2, t naught 3, t naught by 2, and so on. Okay, where basically your omega naught equal to 2 pi by t naught. This is equation 1. Okay, fine. Now actual Fourier. Maybe I will write it a little better. Now actual Fourier series of x of t, that is the actual signal for which I want to compute Fourier series. Let that be given by x of t equal to summation k equal to minus infinity to plus infinity ck e power jk omega naught t, where omega naught is same as 2 pi by t naught. Okay, therefore d by dt of x of t is what? Summation k equal to minus infinity to plus infinity ck into jk omega naught into e power jk omega naught t. Is it correct? Okay.
Yes, sir. Yes, sir. Correct, sir.
Yeah. Okay. Call this as equation 2. But x dash of t is equal to d by dt of x of t, right? Therefore, compare 1 and 2. Because I have the Fourier series of x dash of t in equation 1. And I have the Fourier series of x d by dt of x of t in equation 2 in terms of ck. Okay. Basically here what happens is whenever m is equal to so basically it only contains odd coefficients of your odd harmonics. So what does it mean? Any even harmonic, that is C2m, will be equal to 0. Okay, you just need to compare equation 1 and 2. Okay? If you compare equation 1 and 2, what happens is for every even harmonic, because this guy contains only odd harmonics, only 2m plus 1 omega naught is present, not 2m times omega naught. That means for any even harmonic, this ck into jk omega naught should be equal to 0. When k equal to 2m, of course not equal to 0. Okay, let me consider k not equal to 0 for now. Okay, when k is equal to 2m, implies your ck j k omega naught equal to 0 implies ck is equal to 0. When k is odd, okay, then what happens? You need to compare the coefficients. What is the coefficients here? 4a by jk, this number, 4a by j pi t naught into 1 by k, because 2m plus 1 is k, should be equal to ck into jk omega naught. Your ck into jk omega naught should be equal to 4a by j k t naught into 1 by k. Okay, that is nothing but ck equal to What is this? Minus, yeah, minus 4a by k square t naught omega naught. Is it correct? Yeah, I think it's correct. Okay, but what I know is omega naught equal to 2 pi by t naught. So what we have is that omega naught t naught equal to 2 pi. Put that in this equation. You get minus 4a by k square into 2 pi, which is nothing but which is nothing but minus, did I miss out something? 4a by jk t naught. There is another pi here, right? There is a pi here, you see?
Sir, in CK, you have meant J term will come now.
CK, this j? See, what I'm comparing is, I'm comparing the coefficient of e power in both 1 and 2 for k equal to odd. So the coefficient is nothing but 4a by j pi t naught into 1 by 2m plus 1. And here it is ck into jk omega naught. Is it correct? And they should be equal for k equal to 2m plus 1. Okay. And that's what I'm doing here. When k equal to 2m plus 1, your ck jk omega naught must be equal to 4a by j pi t naught into 1 by 2m plus 1. I missed the pi here. Is it okay? Is this fine? Yes. Can anyone reply?
Okay, sir. Okay, sir.
Okay. Then basically you have another pi here. Then this becomes pi square. So what you're left out is with 2a by pi square k square. Okay. So that means ck is equal to minus 2a by pi square k square whenever k is an odd number. That is 2m plus 1. And when k equal to 0, your C naught is nothing but, use a regular expression, C naught equal to 1 by T naught, 0 to T naught x of t dt, which is very simple to obtain. Just area under the triangle. Area under the triangle is half BH, right? This A by 2. Okay. So now what I have C naught, I have all CK values. Just put that in this expression, A expression, which is a Fourier series of your x of t. Okay. Collect the above values and use in, you can show that your x of t will come out to be, your C naught is a by 2 plus summation, there's a minus 2a by pi square k square. So that is nothing but minus 2a by pi square summation m equal to minus infinity to plus infinity 1 by 2m plus 1 the whole square into e raised to j 2m plus 1 into omega naught t. Is this okay? This will automatically take care of the fact that there will not be any even harmonic in the system, because 2m plus 1 is always odd. There will only be odd harmonics. That's because for even case your CKs are anyways 0. Okay, that is basically a complex exponential. Now you can just verify similarly. Okay, similarly I want you to try. Okay, write down the expression for general. So similarly, what I'm essentially saying is, like this, you write down the expression for trigonometric Fourier series, do a differentiation, you will get something like d by dt of x of t in terms of AKs and BKs, and equate that to the trigonometric Fourier series of this problem, this one. Equate this to this one. And then from there, you find the AK, BK and substitute that in this expression in a corresponding trigonometric domain, and then you will get the trigonometric Fourier series of x of t. I'll give you the final answer. You please check whether you're getting that. your x of t will be equal to a by 2 minus 4a by pi square summation m equal to 0 to infinity 1 by 2m plus 1 the whole square into cos 2m plus 1 to omega naught, where omega naught equal to 2 pi by t naught. Okay, see again, make an observation. Your Fourier series is containing only cos term. Why? Go back to the x of t. This is your x of t. This is completely an even signal. That's why you had only cos term and not the sin terms. Okay.
Yes.
Fine.
Okay, sir.
Okay. Now what I will we are around 7:40. What I will do is I'll just solve one more question and then we can stop for Fourier series. In the next week we will spend complete time on Fourier transform problems. Last question for today, question number 5. Consider the periodic impulse train as shown below. Okay, so how does the impulse train look? Something like this. This is your x of t. Okay, series of impulses. Okay, maybe I'll use different colors. Okay, this is a 0, this is a t naught, this is a 2t naught, minus t naught, minus 2t naught, and so on. It goes on. So it's of course a periodic signal. Okay, each one is a delta function. Okay, that is, you can write your x of t as summation k equal to minus infinity to plus infinity delta of t minus kt naught. Okay, just sum over all these impulse functions. For example, this is delta of t, this is delta of t minus t naught, delta of t minus 2t naught, this is delta of t plus t naught. All of that will, you can sum over all these impulses will be, you can write this as something like this. The question is simple again. Question is A, find complex exponential Fourier series and B, find trigonometrical Fourier series. Okay, so again the solution, this one will be a general way to, I mean the regular way to solve using integration method, but let's solve it anyways. Okay, so for complex exponential, what you have, your x of t is of the form summation k equal to minus infinity to plus infinity ck e raised to j k omega naught t. What is omega naught here? 2 pi by t naught, because what is the fundamental period? Fundamental period is this guy only, t naught. T naught. Okay, so now what remains is to find ck. What is ck? Just go back to the expression 1 by t naught integral minus t naught by 2 to plus t naught by 2 x of t into e raised to minus j k omega naught t dt. Okay, but between minus t naught by 2 to plus t naught by 2, what is x of t? I'm only considering a region. In this region, there's only one x of t here, delta of t. Everywhere else it is 0. Okay, that means it's nothing but 1 by t naught integral minus t naught by 2 to plus t naught by 2 into delta of t into e raised to minus jk omega naught t dt. Now tell me, what is this? Yes. nothing but 1 by T naught into e raised to j 0. Yeah, 1, not 1, right? It's T naught, 1 by T naught. Because except at T equal to 0, everywhere else this is 0. Only at T equal to 1, this delta of T will take a non-zero value. Sorry, T equal to 0. Except at T equal to 0, everywhere else is integrand is 0. But except at T equal to 0, delta of T will take a non-zero value. But at that T equal to 0, this e power will become e power 0, which will be equal to 1. Correct? That is just equal to this. Therefore, it is equal to 1 by T naught. Is this clear?
Yes, sir. Yes, sir.
Yeah. So then it's 1 by T naught. So we now know what Ck is. Therefore, very simple. Therefore, your x of t is nothing but what is the Fourier series? Simple. 1 by T naught summation k equal to minus infinity to plus infinity e raised to jk omega naught t, where omega naught equal to 2 pi by T naught. That's all. Okay. Similarly, what is the trigonometric Fourier series? Okay. So basically, recall that you can write trigonometric Fourier series x of t as a naught by 2 plus summation k equal to 1 to infinity ak cos k omega naught t plus bk sine k omega naught t. Correct? This was the expression for your trigonometric Fourier series, where what is ak? Ak is nothing but, recall, 2 by T naught integral minus T naught by 2 to plus T naught by 2. That is, integration is over one period, minus T naught by 2 plus T naught by 2 into x of t cos a omega naught t. That was my expression for ak. But now again the same, using the same argument, between minus T naught by 2 to plus T naught by 2, the x of t has only one term, that is a delta of t. So this is same as 2 by T naught from minus T naught by 2 to plus T naught by 2 delta of t into cos k omega naught t. Again, delta of t takes a non-zero value only at t equal to 0, where this guy, what is this one? Cos of 0 is equal to 1. Therefore, this entire integration will be equal to 1. This becomes 2 by T naught into 1, which is equal to 2 by T naught. Basically, this 1 is because of cos 0. And basically, what about your A naught? A naught is again you can obtain as, recall the expression for A naught. I think it's 1 by T naught summation minus integral to plus integral T naught x of t dt, which is nothing but, again you can show that this comes out to be 1 by T naught. Now, do you want to guess how to do BK? Okay, same thing. BK is nothing but 2 by T naught minus T naught by 2 to plus T naught by 2 x of t into sine k omega naught t dt, which is nothing but 2 by T naught into minus T naught by 2 to plus T naught by 2. Between this in this range, there's only one term of x of t, which is delta of t into sine k omega naught t dt. Now, what is this value? Yes, tell me.
0.
Correct. Because t only at t equal to 0 will delta of t exist. I mean, will have a non-zero value. And in that case, you will have sine of 0. And sine 0 is 0, so this is equal to 0. Therefore, collecting all the terms, collecting values for A naught, AK, and BK in, maybe where is the expression? Let's call this the equation A. In A, what you can show is that x of t equal to A naught is 1 by T naught, okay, and AK is 2 by T naught. Summation k equal to 1 to infinity cos of k omega t, and dk is anyway 0, so there is no sine term. So this is basically your trigonometric Fourier series. Okay, now again, why is there is no sine? Go back to the figure, do a sanity check. If this is completely an even signal, right? If this signal is symmetric about your y-axis. For an even signal, all your bk's should be 0. That is, no sine term should be there. That's what we have seen here also. That bk's are equal to 0. Okay, so are there any questions? So we'll stop here now with Fourier series. Are there any questions?
No, sir. Thank you. Sir, please upload this video, sir.
Yeah,
In the
yeah.
link,
I am
because I have
basically
joined it. Okay, sir. Okay.
yeah. So basically,